Hello and welcome back for another VMK in the game development series. If you enjoy this VMK and would like to support my website, please go to www.maticknows.com and you can click on the PayPal icon or click on any of the ads found on the side from Google. In this video, I'll be showing you how to implement transparencies. So in our previous videos, what we've got is we have a scene that has some houses and you can walk around and jump in the scene. So in this video, we'll be adding a transparent window in front of the scene so that you can sort of see through it and you can see the objects behind this virtual window. And I'm going to show you how to implement this. Now to start, we're going to have to first clean up some of this code so that it works a little bit more fluidly for the following tutorials. And the following tutorials are going to be a little bit long, so I decided to make the changes in this one, or at least start making the changes in this video. So to start, what we're going to be doing is going into the update game function here. We see the way that the code currently runs is we handle the keyboard, we handle the mouse, we update the player, and then we have pre-render, we call scene to render everything, and then we have a post-render. And let's take a look inside the scene rendering calls here. As you can see inside here, depending on which renderer we're using, we then use the OpenGL game to render the ground or the houses. Well, what we've done here is we've actually put all the rendering code into our GameOGL class. So we can see here we have render triangle, render house, and so on. But this isn't really a clean way to do it, because you can imagine we may have like 100 different objects. So in the end, we'd need 100 different render calls inside this game. So to clean this up, what we're going to do is we're actually going to take this rendering code for the house, let's say, and instead of putting it inside GameOGL, we're going to put it into the house class. And then here, instead of using GameOGL to render it, we're going to use the house to render itself. So this is going to give us a better interface to work with so that we don't have all these extra rendering calls inside GameOGL. So to make this change, let's start with the ground, which is a triangle, and make that modification first. So now we're going to add a render call in here, and it's going to return a boolean. And we need to accept a graphics renderer type. And the way we've defined that is using graphics render here. So we're just going to do that. Okay, and because we're using graphics render now, we need to include something so that this code will know what a graphics renderer is. And graphics renderer happens to be defined in core.h, so we need to include core.h at the top. Okay, so that's going to fix this part, and now we need to move the code from GameOGL into our triangle.cpp file. Let's put it down here and take a look at what we have. We have a switch statement which branches depending on which renderer we're using, and we're currently only working with OpenGL, so we only have one case here for OpenGL. And the code here to render is exactly the same as the code we had located before. And again, we can go into here, this is render house, and here's render triangle. So we go and rotate the object, and then we change the color and have all the vertices. Well, it looks like we're missing the rotate in the code I just pasted, so let's go and copy that. And we can take out this try now, because try is no longer needed because we're not passing it into this function. Instead, we're using our own triangle member within this class, so we can just use the member variables directly. Okay, that compiles. Oh, we got an error message. It's not a member. Okay, let's take a look inside our ColorOGL here and see how we define it. Oh, right. Inside here we have red, green, and blue, but I labeled it differently. So I'm just going to correct this and make these all members like this. So we're going to have to make some modifications here. Okay, I think that should do it. Let's try compiling that again. Okay, so that's okay now. So now what we can do is go back into our rendering for the scene and change the way that this is structured. We no longer need to use the pointer for the GameOGL. Instead, we're going to use MP ground and and instead use the render function, and to it we're going to be passing renderer like this. So now we can also take this out and see if we can build this and make sure that everything is still working. Oh, we have another mistake here. Oh, right. Now, since we went ahead and changed ColorOGL, we now have to make the changes for everywhere we ended up using it. So here we have to just quickly add in all the M underscores. Okay, and if we run it, we should still see everything exactly the same as we did before. Okay, and we still have the green ground below us. That's good. So now let's go and make those same changes for the house as well. So again, we can might as well just delete these and open up the house.h and the house.cpp file. As a matter of fact, let's just copy the code from here since it's going to be the same. And then inside the house.cpp file, we're going to add the new code here. And let's just go through it very quickly. We have, again, the same switch statement, and then if we're using OpenGL, we push the model view matrix onto a stack, translate the house, rotate the house, change the color, and then render each of the faces of the house for the body as well as for the roof. And then pop the matrix at the end. Let's see if this compiles. Okay, and then go back into the scene. Now let's make the change here as well. And let's run this to make sure everything's still running. Okay, so that works. Now, because we no longer have a need for that GameOGL pointer, we're just going to go and remove it. Oh, we have an extra bracket here. There. We can go and remove the pointer to the GameOGL class from scene.h, since we're no longer going to be using it. So in here, this one here, we no longer need this. And, oh, okay, we just have to make sure, yes, there was that one part we had to also remove. Okay, so now that we've made those changes, we can start working on adding transparency to the screen. So to do this, what we're going to do is I'm going to use one of these triangles and I'm going to place it in the scene so that it's right in front of your eye when you first start, so you can see sort of through it and see the houses that are behind it. So I'm just going to change the name of one of these to be MP window. And we won't be using these, so I'm going to just delete them. Okay. And then down here we need to initialize our window. So what we're doing is we're taking that pointer, we're creating a new memory for it, for a triangle, and our first vertex, our second vertex, our third vertex, no rotation, and the color of the item. This color is kind of a yellowy color. And if everything works, then it'll just continue through here normally. Then let's go down here and we can delete these since they no longer exist and replace this one with window. Okay, and from here we need to go and render that window. Oh, since we're always passing render now in the renderer into our render function, we can actually also remove this if statement since we no longer need it. Let's see if this builds. Oh, we never overloaded the constructor, so let's do that as well. So we need to go and modify the constructor in ColorOGL. And we'll put it on the bottom here because we're going to call one of these set functions inside the constructor. So to be able to call them, the constructor will need to know about them, about the set function. So we need to put them underneath. And we're going to pass in 3 variables, just like this. So we're passing in the red, green, and blue value and into the constructor, and inside the constructor we just call the set function. And the set function, located up here, is just going to set the red, green, and blue value to the member variables inside our structure. Let's see if this builds. Oh, now because we've created this this one constructor here, we also have to create a default one since we don't have a default one currently. And the default constructor, actually I'm going to put it right at the top since it's going to be the default. So we'll put it right here. So if you don't pass in any values, then we're just going to set the color to be black, which is 0, 0, 0. Okay. Alright, and let's run this to see if we can see that triangle. Okay, so here's our triangle, which is in front of our scene. You see I've sort of placed it so it's horizontal along the top, and then the point of it is actually below the surface of our object here. And we can't see through the bottom face here, so we can't see the bottom peak, but it just gets cut off at a straight line there. Now, if we want to make this triangle transparent, we have to go and modify the color class, because transparency is actually stored as an alpha value in the color, so we need to add an extra member here. Now, since we're going to be modifying this color OpenGL structure, I've decided to replace the structure with a class, since then we can add a little bit more functionality and do a little bit more with it. So to do that, what we're going to do is just create a new ColorOGL.h file, put it in our project here, and move all this code into that .h file. So to begin, let's delete the structure here. And now let's go and create a new .h file we'll be using. We're going to put it inside GameOGL. So select this and then click on New. And browse to put it inside the GameOGL folder. And let's call it ColorOGL. Okay, as you can see here, at the very bottom we have 4 private members now. Before we had, or public members. Before we had the red, green, and blue, but now we're adding this floating point value for alpha. And alpha is going to control whether our object is transparent or opaque. So let's go to the top here and I'll walk through all the changes that have been made to the color. We have constructor, and notice that all the code is being written inside the .h file because I'm using the inline keyword here. Now, the reason why I've chosen to do this is because color is going to be called quite a few times in our code, so I want it to run as quickly as possible, so that's why I made all the functions within the ColorOGL class inline. So the default constructor, again, has red, green, and blue defaulting to 0, which means we're setting the color to black, and I'm setting the alpha value to 1. If you set the alpha equal to 1, this means that your object, which will be black, is going to be opaque, meaning you can't see through it. It's going to be a solid color. We have our set function, and we have the same code here for the error checking for red, green, and blue, but I've now added this extra error checking for the alpha value. The alpha value can only go between 0 and 1, again. If it's 1, it's opaque. If it's 0, transparent. And anywhere in between, you have sort of a translucent kind of look. And again, we have another set function here using integers rather than floating point numbers. And same thing here for the alpha. It's only allowed to go between 0 and 255. And then we have constructor, which accepts red, green, and blue value, and there's a 4th optional parameter called alpha. If you do not set this 4th parameter equal to a value, then by default it's going to be using the value equal to 1, which means that it's going to be opaque. If we do set it to something, then it'll use whatever we set it to instead of 1. So that's just like a little way of handling default values. And whatever gets passed in automatically gets passed into our set function. And I have the same thing using integers. We have a virtual destructor. This is this operator. And what it does is it multiplies the current color stored in the class by a scalar value. So by doing this, you can scale the color to make it darker or lighter. So if you multiply it by small numbers, you're going to be scaling the red, green, and blue values by smaller and smaller numbers. Therefore, the color is going to be going darker and darker into black. And if you scale your color by higher numbers, then you're going to be increasing the values of the red, green, and blue, which is going to cause your color to get lighter and lighter and more towards white. So if we look at the code here, we see we take the red value, we multiply it by the scaling value, and then we store it in this temporary color variable here. Then we check to make sure that the color is still valid. It has to be between 0 and 1. If it went out of range, then we just saturate it to the limits. And then we do the same thing for the green color and the blue color. And then after we have all three, then we just return a new color using the red, green, and blue that we just calculated, and then the same alpha value that we had before. We don't change the alpha. Okay, so that's our new color class. And Let's try building this. We're going to get some error messages since we took out the structure, and all of our classes that are using ColorOGL will now not know where to find this new class because we haven't defined, or we haven't included ColorOGL.h in any of our code yet. So we're going to need to do that now. So in Triangle, we're using ColorOGL, so we have to now include it in here. Like this. And in House, we're using it as well. So we can go in and actually just copy it from Triangle. In House, we're using vertexes and colors. So actually, we don't need Triangle. We can just replace that with color. And House, Game uses OpenGL. So up at the top here, we can go and add it there as well. And it looks like Scene uses color. So in our scene.h file, we're going to need to add ColorOGL as well. Okay. It looks like we're missing something here. Missing bracket identifier after position. Okay, we're using vertex here, but we're missing vertex. And in the House, we're using graphics renderer, but we forgot to include core, so we can include core here instead of air handler, since air handler is included in core. And I think that might be it, yeah. So let's give that a run. Okay, so we're back up and running. Now, what we can do is start playing around with the alpha value to see that yellow triangle start going transparent on us. So under Scene, in initialization, with the window, we're passing in the color at the very last value here. Well, we can now go in and set the alpha value. Oh, I guess we can't set the alpha value this way. We need to convert these 200s to floating points, or we can go in and add the alpha value to the constructor as well. Might as well add it into the constructor, since if we're going to be using it now, we might as well make the change now. So here we, where is the constructor? Okay, here we have the constructor for floating point numbers, but the constructor for integers didn't have that alpha. So let's go add it in. And we just have to make sure that we have a set with an alpha. Okay. Oh, we're going to get an error message because I modified the code here. Okay, we can now, we should be able to add the alpha. Yep. Okay, so if we add an alpha value for, let's say we want it to be 255, this should remain fully opaque on the screen. Okay, and now if we change this to be, let's say 128, we should have it half opaque. So in other words, partially transparent. Well, we don't have it partially transparent yet. Now, the reason for this is there's one other thing we need to do for OpenGL to handle the alpha values correctly, and that is called blend. So for OpenGL to be able to handle transparencies correctly, you need to define how it's going to be blending colors on the screen. And to define that, we can go into our GameOGL initialize, and under here we have shade smooth. So this is how we want to shade our objects, and underneath that we're just going to add this line of code here, GL blend function, and we're going to choose source alpha and 1 minus source alpha. Now these parameters here are described in MSDN library. If we go take a look at GL blend function, you can go read through the description here for what the S factor and D factor represent, and here are all the different values. But if you read through here, it tells you how all the math is handled to do the blending. But under the description for the examples here, it says transparency is best implemented using GL blend function alpha and 1 minus alpha. That's what we're using right now. Okay, and blending, the way it's going to work is it's going to take a value for a pixel and blend it with the new value that we render on top of it. Now, this operation is kind of, you can say, computationally expensive, so there's a way to actually turn it on and off. We don't have to always blend every single pixel we render on the screen. We can just choose which pixels we want to render, or which pixels we want to blend. So to do that, let's go into our triangle render. Since we're going to be making the triangle transparent, I'm going to go and enable it here. And then after we enable it, we go and render those pixels, and they're all going to be blending. But once we're done this, we're going to go and call GL disable blend. So it's only ever going to be blending triangles on the screen. Now let's build this and run it and see if our triangle is transparent. And still it's not. Okay, the reason why it's not blending yet is because we've stored the alpha value inside our color here. However, the value we've stored we haven't been using, so that's why we're not blending anything on the screen. One thing I did notice here is that this should be actually a 255, not a 1.0, because this is an integer. So let's go into triangle render. Now, instead of using color 3F, which passes just red, green, and blue, we now have to use color 4F, because we also want to be passing in the alpha value as well. Alright, now I think when we build, we should be able to see a transparent. Yes. Okay, so there we go. We have our transparent yellow triangle. Now, I want to point out a couple things about this blending. It's very important in which order you render your objects. And let me demonstrate this. Let me open up the scene file under update. And let me show you what happens if I were to take this render and I render it after I render the second house. So in other words, I render the ground, I render the first house, render the second house, then I render a transparent window, and finally I render the third house. Let's run this. And let's see what we see. We have a triangle. We have one house on our left and one house on the right. Well, where's our third house? If we look around, we can actually see it's there. It's behind our window. But when we look through the window, the house disappears. Now, the reason why this is happening is because of the order that we're drawing things on the screen. So we've drawn our first house and our second house. So, well, think of it this way. You start off with a blank piece of paper. On the blank piece of paper, you draw the ground, which is the green part. Then you draw the first house. Then you draw the second house. Then you draw the triangle, which we're looking through, which is our window. And finally, we draw our third house, which is the house we don't see. Now, we draw the third house on the screen, but because the depth buffer is turned on, it knows it's not supposed to render it because it's behind our current window. So it doesn't know that the transparency is turned on, so it just doesn't bother rendering it. However, whenever it is visible to our eye, it does render it on the screen because it's not occluded by the window that we're drawing. So this is something that OpenGL does for us automatically whenever we have the depth buffer turned on. Let's turn off the depth buffer and take a look at what happens. And we can do that inside Initialize. We have the depth buffer. Where is it defined? Here it is. Enable depth test. So if we just disable this, we now will not allow OpenGL to automatically handle the depth buffer for us. So let's run this and see what our scene looks like. Notice our house does get drawn on the screen now, but it's drawn, it looks like it's drawn on top of everything else. It's actually in its proper spot in the scene, but it overlaps the parts on the screen that are not really supposed to overlap. And this is because our depth buffer is not working for us. We basically disabled it. So our objects are all look funny because they're not being rendered properly. So it's a good thing to have the depth buffer turned on. However, you have to remember when you have the depth buffer turned on and you're using transparent objects, you could run into problems if you don't sort your objects before you render them. So make sure that you're aware of which objects are where relative to the eye or the camera in the scene. If you render them in the proper order, then transparent objects will look correctly. If you render them in the wrong order, then you won't be able to see the objects behind transparent objects because they get cut off automatically by OpenGL. Okay, so come back again for the next tutorial, which will be discussing different light sources.